Okay, today we're talking about differences in proportion. So basically doing a two sample t-test for means, the differences in means. Okay, so conditions are pretty much the same. The only change is going to be you have to check both samples, right? So both samples have to be random sample, both have to be less than 10%, both have to be large sample. Same conditions as we had for the last test, basically. Okay, this looks like they're using data here. So we'll go through the next example a little bit more in depth, but let's just talk about this one. So a college student wants to compare the cost of 1 and 2 bedroom apartments near campus. She collects the following data. So 1 bedroom, they selected a random sample of 10 apartments of that type. And the costs, and then 2 bedroom, those are the costs of 10 randomly selected 2 bedrooms. Of course, we're going to define the variables first, right? So we're going to, the parameters in this case. So M1 is the true mean monthly rent. We're not talking about proportions, we're talking about means of all 1 bedroom apartments near campus. Again, we're describing the population here. So don't say of the sample, we're describing the population. The true mean monthly rent of all 2 bedroom apartments near campus. So we're going to check the conditions. So the conditions, again, are, first is a random sample. I think it says something about random sample of 10 apartments. Underline that, write the word random sample, you got it. Is it less than 10%? We're going to assume that 10 1 bedroom and 10 2 bedroom, both respectively, are less than 10% of all the apartments of that type near the campus. So that just means there's at least 100 1 bedroom and at least 100 2 bedrooms. That's a very safe assumption to make. In this case, the sample size is only 10, so it doesn't pass that. We don't know about the population shape, so if that's normal or not. So you pretty much have to draw the graph here. And so you are going to need to take that data, maybe draw some dot plots or box plot, whatever is easy, but dot plots are usually probably the easiest. We're not looking for it to be approximately normal. We don't have enough for that, but we are looking for something not to be. No major skewness, no outliers. And both those look okay. They're not perfect, but they're somewhat spread out, somewhat symmetric, and so we're going to go with it. Passes the test. This is the generic formula. So the statistic, like X bar, what we used last time, is going to be the difference in the X bars. Instead of standard deviation, because we don't know the population standard deviation in most cases, we're going to use the sample standard deviation in the formula. So that's the formula for the interval. So pretty similar to what we just did, but the standard deviation, standard error formula is a little different part there, and then we're finding the difference instead of just the X bar at the beginning there. So now you might want to get out, this sheet of paper here if you have this from class. Or at least this is what we did in class here. So let me just kind of get that out. If I can click on it. There it is. Okay. And I'll get my calculator out in case I need it. Okay, so the Wade Tract Preserve in Georgia is an old growth forest, longleaf pines that survived in relatively undisturbed state for hundreds of years. One question of interest for foresters who study the area is, how do the sizes of these pine trees in northern and southern halves of the forest compare? To find out, members took random samples of 30 trees from each half, measured the diameter at breast height, so dBH that's called, in centimeters. Here are the summary stats from that off to the right there. Construct and interpret a 90% confidence interval for the difference in the mean dBH of longleaf pines in the north versus the south of this particular preserve. What's the parameter? So the parameter would be, mu1 would be the true mean, let's see, what's it asking for? dBH of longleaf pines in the north of the Wade Track Preserve. M2 is the true mean DBH of the trees in the south part of this preserve, something like that. So define both variables, mention the confidence level. So this is 90% confidence level here. So we got it. Inference method, this is a 2-sample t interval for, you can either say in words the difference in means or just say mu1 minus mu2. We're going to use stats. Those are the stats we needed. All the stats we need are really right there. So to do our test here, or interval. Okay, does it pass the conditions? Random sample. Took a random sample of 30 trees, so we kind of draw that over to this random sample, write the words random sample. Less than 10%, so 30 is less than 10% of all the trees in that, in each part respectively. So since they're both 30, you could probably word this so that you say in both the north and south part of the Wade Track Preserve. So we don't know about the population shape. N is big enough, so we'd say something like N1 is greater than or equal to 30, and N2 is greater than or equal to 30. So interestingly here on the degrees of freedom, so it's not cut and dry. You have a choice. I want to tell you about this choice just because on other problems that they might work, they might make this choice and it might confuse you if you've never heard of it before. So we're going to use the calculator to get our degrees of freedom, but this is the other way of doing it. The smaller of N2 minus N1. So let's say that N1 was 20 and N2 was 40. So using the conservative valuation here for degrees of freedom, you would take the smaller of the two numbers, 20, subtract 1, and that would give you 19. That would be okay if that was the problem. We're not going to do that. So get your calculator out and follow the directions down here where it says 664. So menu, 6 is stats, 6 is confidence intervals, and 4 is 2-sample t intervals. And we're going to go with stats here. Okay. So there we are. There's our stats. So let's find it. So x1, I'm going to consider north my x1. So the mean is 23.7. Standard deviation of the north is 17.5. The sample size is 30. The south is 34.58. Whoops. 14.26 and 30. Now be careful. I want you to scroll down here. So if you see that there's a little scroll bar, or you can hit tab. Sometimes I hit tab. Okay, so first of all, we definitely need to change that. That's 90, I think now, or 0.9. And this is the one I want you to see. So there is a choice down here of do you want to pool or not? Now, pooling is kind of like what we did with that p-hat common value, or the I don't know the name for it, but it's when we did the x1 plus x2 divided by n1 plus n2 p-hat values, like a special value we use with two props, I think, two-prop test. Kind of like that. We don't do that on this one. So when the calculator asks you, just say no to pooling. You want to just say no, so I'm going to say okay. If you mouse up one click, you can see pretty much all you need to see there. So it's got it crunches all the numbers for us. Except for, I would say this, we need to figure out a t-critical value. So to get that t-critical value, because degrees of freedom it does say is 55.7, so I just got that from the calculator. We understand that you get it from the calculator in that case. Critical value, so if we're 90% is here, there'd be 5% on the left. So you would go to the menu 656, I believe. Area is 0.975. And you're going to put the degrees of freedom we just found, 55.7 is what we found out it was. So you get a t-critical value of 2.003, or about 2 would be fine to say there. So that's the one. You do have to find that t-critical value by hand. Now, let me go back to it so I can see the data. So there's the data. I'm just going to plug into the formula here. So this is equal to, x2 minus x1. So 34 no, x1 minus x2, 23.7 minus 34.53 plus or minus 2, because that was pretty much 2 for our t-critic value, times the square root of standard deviation of 1, so 17.5 squared over n1, which was, I think, 30, plus S2 is 14.26 squared over 30. And you could type that in calculator, but you don't really need to. The one part I would do, I'm just going to show you, so what I would consider doing is maybe, because I don't think they do it for you, didn't notice this, so 23.7 minus 34.53. So I get negative 10.83 plus or minus. If you scroll back up on that one, you're going to see the margin of error on the calculator. So 6.89 plus or minus 6.89. And then you're going to draw your interval. According to the calculator, it's negative 17.7. If you did it the other way, you're going to have a slightly, those are going to be positive. And then negative 3.93 or 94. Okay, interpret interval. We are 90% confident. The interval from negative 17.7 to negative 3.94 contains the true difference in means of the PDH or whatever that thing was, that abbreviations of the DBH in the northern forest versus the DBH in the southern forest of this preserve. I'm just going to go through the PowerPoint so you can see how they wrote it. Maybe they wrote some things better. You can stop and pause it if you need to. So that's what they said for the shape. Oh, they asked a different question. So they had an extra question here that was not on my paper. Based on the graph, write a few sentences to compare the size of the trees in the two halves of the forest. Use comparative words. One is larger than the other. Like you can probably see the median of the south is greater than the median of the north. That would be a great thing to say. The standard deviation or the range of the north is greater than that of the south. So this is what they said. The north is skewed to the right, the south is skewed left. No outliers, clearly. The center, again, just like we said, and variability, just like we said. Okay, then they said construct the interval, check the conditions, show your work. We are 99% confident. Okay, perfect. Say no to pooled data. They understand that that a lot of students will use the calculator for this one, but you could use the more conservative estimate. That's going to give you a wider margin of error, which really is not desirable. We'd rather get a smaller one, so it'll help to actually do it that way. Go ahead and try this one. Stop it, and try this one. See if you can do this. You have to type in the data twice. So once into one list, you go to your list and spreadsheet, type in the data like we did the other day, and those are the answers if you want to check your work. Okay, that's the lesson for today.